Let us now conclude our discussion regarding the solving of problems falling under the category of the equilibrium condition. So for problem number 4, what tension in the cable BD, which is ito, no, would exist as a result of the placing of the 1,000-pound cylinder? Another question is, what reaction exists at pin A? So again, it is actually necessary for us to be able to create the correct or necessary free body diagram. So again, in this case, ang free body diagram na gagamitin natin dito is not only confined to one free body diagram. So, bigyan ko idea regarding do sa number of possible free body diagrams na pwedeng gamitin. Kung yung figure natin is more or less composed of separate bodies, most probably yung figure na to o yung problem na to would involve or would entail more than one free body diagram. Pero let's say for example, ang mga problems natin is in the form of trusses or truss. So, ang free body diagram niya is more or less limited to one free body diagram. So, in this case, so yung problem na to, kung papasin natin, meron tayong bar AB and then meron tayong cable BD. So, yung cable BD and then yung bar AB, pwede natin siyang gawan ng separate free body diagram. So, itong 1,000-pound cylinder, pwede rin natin siyang gawan ng another free body diagram. And then, last one, as a whole, pwede tayong gumawa ng free body diagram for the whole configuration. So, all in all, we will be making use of 3 free body diagrams. But for the time being, papakita ko lang muna sa inyo yung applicable free body diagram para sa whole configuration. So, free body diagram, 1 out of 3. So, for the whole configuration. So, ito yung natin, no? So, ang tendency nito is ganito. So, meron tayo ditong cable. So, ang tendency natin sa cable to is ikakat natin siya sa part na ito. So, cut natin yung cable dito. And then, if i-free natin yung bar AB nito, vertical bar AB nito, with respect dito sa pin at A. So again, kung papansinin nyo, in-anticipate natin sa A, since meron tayong pin, it is actually composed of 2 reactions. Isang horizontal, tapos isang vertical. Again, yung kanilang corresponding direction, didepende pa rin siya doon sa tinutukoy nating condition called equilibrium. Another one is ito. Meron tayo ditong cable BD. So again, cables are always subjected to the force of tension. So, since yung cable natin is placed not vertically or horizontally, lumalabas, place siya at an inclination. So, ang tendency nito is kinakailangang i-breakdown natin siya sa kanyang X and Y component of a force. So, kung titingnan natin dito, gawin natin siyang free body diagram. So, again, yung direction ng pinaka-arrowhead natin dito, papalayo doon sa direction kung saan nakakonekta yung mismong pinaka-cable natin. So, para ma-replicate, masabi natin siya is actually under the concept of tension. So, since ito is BD, ito is labeled as TBD. Yan. So, kung titignan natin yung configuration natin dito, so again, gaya sinabi ko sa inyo, for as long as meron kayong makikitang forces, reaction, loads, or tensions na inclined, automatically we should break this up into its X and Y component of a force. So, yun yung gagawin natin. So, be-breakdown natin siya. Yan. So, kung ito is TBD, ililabel ko to as TBD of X. So, ito naman yung kanyang Y component. So, ililabel ko naman to as TBD of Y. So, another one is sa cylinder, merong cited description dito na meron siyang weight. Ang weight ng cylinder natin is 1,000 pounds. So, dapat nyo lamang tandaan is that weight is always considered to be a downward vertical component of a force. So, with that being mentioned, lumalabas ito, no? So, you have here 1,000 pounds. And then another one is, since ginawa natin siyang free body diagram, tatanggalin din natin itong inclined surface kung saan merong contact itong pinaka-cylinder natin. So, by the way, kung titignan natin, dahil sa inclined surface na to, ito yung nagkikip dito sa cylinder nito from staying put in its stationary position. So, in this case, lumalabas, kung ito man si inclined surface, si inclined surface, nagbibigay siya ng reaction papunta doon sa direction ng cylinder. So, para ma-maintain niya o para nape-prevent yung cylinder nito from falling downwards. So, in this case, meron tayong reaction provided by the surface papunta do sa roller. So, ang reaction provided by the inclined surface is actually inclined. So, as can be seen din dito, no, sa mismo pinaka-itsura ng pinaka-sign pen natin. So, in this case, si surface, magbibigay siya ng reaction. So, kung papansinin din natin yung reaction provided by the inclined surface, so, inclined reaction. So, in this case, since meron naman tayo ditong reaction which is a form of a force, so, i-breakdown din natin siya. So, breakdown natin siya. So, label na lang natin to as R. Yan. So, gumawa na lang ako ng location. So, nilabel ko siya as R. So, since ito is actually inclined, i-breakdown natin siya. Yan. So, this is R of Y. Ito naman is R of X. Ayan. So, kung papansinin nyo, no? So, pag magbe-breakdown kayo ng corresponding components ng X saka Y, i-breakdown nyo siya either sa pinakadulo or do sa pinakasimula niya. So, in this case, ano, papansinin nyo, yung reaction provided by the surface is actually in contact dito sa mismong pinaka arc na mismong pinaka cylinder. So, doon tayo nagkaroon ng breakdown. So, in this case naman, since yung pinaka cable natin is actually in contact or connected at the B portion, dito tayo magbe-breakdown. So, dito tayo nga nagkaroon ng breakdown ng X as well as Y, di ba? So, yan. Then, last one is actually ito. So, titingnan natin, no? Sa A, meron tayong makikitang pin. So, as was previously mentioned, basta't meron tayong pin, yung pin, nagbibigay siya ng dalawang reaction, isang X as well as isang Y. So, ito is RA of X. So, papansinin natin, dalawang possible direction. So, either in direction niya is going to the left or going to the right. Now, kung titingnan natin yung configuration natin dito, at one end, meron tayong reaction directed to the left. And then, almost at the middle, meron tayong horizontal reaction towards the right. So, most probably, ang RA of X natin, most probably, no, mas mataas yung chances na yung RA of X natin is going to the left. So, kung papasin kasi natin, kung ito siya, ito yung laban, no? So, nagkakontrahan itong dalawang to at both ends. Then, yung middle, dito, sa pinakagitna niya. Diba? Then, last one would be itong RA of Y. So, in terms of RA of Y, since wala tayong idea kung sino mas mataas kay RY sa dito kay 1,000 pounds, dalawa yung possible direction ni RA of Y. So, either si RA of Y is going up or si RA of X, RA of Y uli is going down. So, again, it will all boil down in the end kasi in the end consider natin yung condition called equilibrium. So, kung i-assess natin ngayon yung corresponding configuration, unknown si RA of Y, unknown si RA of X, so unknown din si R or si RY, RX, as well as si TBD of X. So, in this case, kung papansin natin, there are multiple unknowns dito sa ating whole free body diagram. So, as was previously mentioned, kung gumagamit kayo ng isang configuration tapos maraming maraming unknowns or there are multiple unknowns, most probably ang sinasuggest nung pinaka-isolation na yun, ang free body diagram na yun, is hindi siya po pwedeng gamitin or gawin. So in this case, hanap tayo ng iba pang possible free body diagram. And then, kung papansin nyo, no? So as was previously mentioned, ang iba pang possible free body diagram is yung cable BD, which is actually connected or tied dito sa vertical bar, which is AB. However, ang problem natin, kung consider natin yung isolation natin of free body diagram dito sa bar AB, kung saan meron tali or cable BD at its end, ang problem natin dito sa isolation of free body diagram to is wala siyang given condition. However, kung titingnan natin yung isang part dito, nandun yung kanyang given condition, which is 1,000 pounds. So, ang idea lamang is, para masabi nyong applicable or magagamit natin yung free body diagram, there should be a given condition, which is necessarily makikita natin dito sa cylinder na to. So, base sa cylinder na to, ang cylinder natin has a corresponding weight of 1,000 pounds. So, again, pag sinabi natin weight is always considered to be a vertical downward component of force. So, lagyan natin siya. And then, dapat yung tandaan, weight is always located at the center of gravity. And then, for figures, plain figures such as circles, squares, rectangles, or even regular hexagons, ang tinutukoy nating center of gravity kung saan makikita natin yung weight is makikita natin siya midway o nasa kalagitnaan. So, yun din yung reason kung bakit nilagay ko yung center of gravity o yung C natin dito at the middlemost portion of the cylinder. So, lalagay natin dito is 1,000 pounds. So, gayahin na lang natin yung reaction. So, yung reaction, meron ditong reaction ulit. So, reaction provided by the inclined surface. So, again, since yung reaction natin dito is actually inclined, i-breakdown natin siya sa kanyang x and y components of force. So, Rx, ito naman is Ry. And then, kung papansinin nyo, since in-isolate natin yung cylinder na to, tinanggal natin yung surface o yung pinaka-vertical bar, which is AB. So, dahil dito sa vertical bar AB nito, saka dito sa inclined surface natin dito, yun yung dalawang reason kung bakit na-stay put natin yung pinaka-cylinder na to at its current position. So, mean to say, without the presence of the vertical bar AB, ang tendency ng cylinder natin is also to fall downwards. Mag-roll over siya towards the right. So, mean to say, at A, kung titignan natin, no, at E, may pumipigil sa kanya from moving downward or moving to the right. So, meron tayong horizontal o merong reaction na pinoprovide. May reaction na pinoprovide itong vertical bar AB natin papunta doon sa E. So again, kung meron kayong plane surface o again meron kayong surface at yung surface na to nagkataon plane surface, itong surface na to mag-exert siya ng perpendicular reaction. Perpendicular with respect to sa pinaka-plane surface. So, base doon sa sinabi ko sa inyo, ito na ngayon yung reaction provided by the surface of the vertical bar AB. So, since ang location natin dito is E, label ko siya as RE. Okay. RE siya. Then, hanapin na natin yung mga corresponding angles. So, pinaka-most important part dito is angle. So, check natin, no? So, kung ito is 60, so, 60 rin to. So, since ito technically is angle of 90 degrees, so, 60, 90. So, I mean to say, meron matitira ditong 30 degrees. Yan, 30 degrees. Then, kung titingnan natin siya, ang angle natin dito is 60 degrees. Once again, diba? Yan. So, kung titingnan natin dito, no? So, 60 dito, 60 dito. Most probably, 60 rin dito. So, technically, kung meron tayong right triangle na kinakailangan-observe dito, ang right triangle na ma-observe natin dito is 30 by 60. So, kung iayos natin yung configuration natin dito, ano, so hindi lang medyo maayos yung illustration ko dito, no? Yan. So, base dito sa ating right triangle, ang lalaro-laro ilang natin dito mga corresponding angles is 30 by 60. Yan. So, 30 by 60. So, kung titingnan natin itong corresponding configuration, hanapin natin 30 degrees, hanapin natin 60 degrees. So, most probably, ito is 60 degrees. So, sabihin natin ito is 60 degrees. 60 to. Kung ito is 60 at ito is 90, mean to say, ito is 30 degrees. Then, kung titingnan natin, gaya sinabi ko sa inyo, kung magpa-project kayo ng reaction, kung magbibigay ng reaction ang isang plane surface, ang reaction na to should be at an angle of 90 degrees or perpendicular. So, tama lang din siya. So, paano naging tama? Kasi kung titingnan natin to, no? So, kung ito is actually 30 degrees, 60, so ito is another 60. So, 60 plus 30. So, 60 plus 30. So, you have 90. So, tama lang yun sa sinabi ko sa inyo na basta't meron tayong isang plane surface, si plane surface na to, magbibigay siya ng reaction, tapos kinakailangan perpendicular respect sa kanyang plane surface. So, yan. So, kung ito is 60, ito din is also 60 degrees. Yan. So, lipat natin mga corresponding angle natin dito, no? Yan, ito. Mas makatotohanan na yung 60 degrees approximate na to. So, 60 degrees natin dito is yung tinutukoy nating theta of x. So, in this case, ano? So, again, ang formulas natin, kung i-list down ko siya, so, formulas to be used, 1, summation forces vertical, 2, summation of forces horizontal, then 3, summation of moment. So again, once again, all three equations should be equivalent to 0. So ayan. So ang tanong dito is, kung i-assess natin tong free body diagram na na-generate on the part of the 1,000 pound cylinder, which among the three formulas na applicable sa equilibrium yung applicable dito? So, tingnan natin. So, on the part of the cylinder, wala kayong makikitang dimensioning or distances. So, meaning, kung walang dimensioning or distances, hindi applicable si moment summation. Kasi, again, kung i-recall nyo, moment summation is described as the product between force multiplied by the perpendicular distance. So, since zero distances dito, o zero distance on the part of the cylinder, at wala din naman sinasuggest na kung ito yung corresponding diameter niya, ibig sabihin nun, ang applicable formula lang natin for this particular isolation is vertical equation saka yung horizontal equation. So, assess natin yung configuration natin dito. So, ang given data natin dito is 1,000 pound. So, ang orientation, ang klase ng 1,000 pound is vertical. So, meaning say, kung mag-start man tayo sa y or sa x equation, gagamitin natin yung y equation. So, simply being, ang given natin dito is a vertical component of a force. So, gawin na natin. Summation forces vertical. So, unahin natin yung data, 1,000 pound. Negative 1,000. So, dalawa lang naman yung vertical dito eh. Isang 1,000 pound tapos isang Ry which is going up. So, positive Ry. So, since dalawa lamang to, pwede na natin isarado yung y equation natin is equivalent to 0. So, ayan. So, this case, breakdown natin yung y. Again, kung nare-recall nyo, so, equate mo na natin, 1,000 is equivalent to Ry. So, again, si y, pwede natin i-breakdown. So, r sine ng angle, which is theta of x. So, which is r sine ng 60 degrees. So, in this case, lumalabas yung r value natin is, you have what? So, r value natin is, you have 1,000 divided by sine ng 60. So, you have 1154.7. So, 1154.7. So, 1,154.7 pound. Ayan. So far, kung titingnan natin, meron tayong value ng R. So, in this case, gamitin naman natin yung isa, yung ating X equation. Summation forces horizontal, all forces going to the right are considered to be positive. So, again, kung titingnan natin, dalawa yung horizontal component ng force natin dito. So, isang going to the left, the other one is going to the right. So, most probably, tama lang to. So, yung sabihin, yung assumption natin on the part of R, so, yung R direction is said to be correct. So, in this case, Rx is positive. Minus Re is equivalent to 0. So, again, breakdown na natin to. So, once i-breakdown natin to, i-breakdown natin siya, no? So, Rx, breakdown na natin siya properly. So, you have R cosine ng theta of x is equivalent to Re. So, you have R value 1154.7 cosine ng 60 is equivalent to Re. So, Re value, so, compute na natin Re value, 1154.7 cosine times cosine ng 60. So, you have 577.3535. So, 577.35 pound. Ayan. So, meron na tayo so far na R. Meron din tayong Re. So, kung titingnan natin yung configuration natin dito, sabi ko nga sa inyo kanina, tatlo yung possible free body diagram. So, consider muna natin yung dalawa. So, yung free body diagram ng mismong pinaka-cylinder, tapos yung free body diagram nitong pinaka-cable BD as well as ng vertical bar AB. So, kung titingnan natin itong configuration natin, yung dalawang parts na to are actually adjoined or connected dito sa may point at E. So, kung nare-recall nyo yung previous example, gaya ng sinabi ko sa inyo, for as long as meron tayong common point or common location kung saan adjoined yung dalawang object o dalawang part na yon, we could be able to locate the same reaction, albeit in the opposite direction. So, ang point ko lamang dito is actually ganito. Yung Re na to, na makikita natin on the part of the 1,000 pound cylinder, is makikita din natin yung Re na yun on the part of the vertical bar AB along with that of the cable PD. So, sabihin, si Re gagamitin natin at 577.35 pound. However, hindi na siya directed to the left. Rather, yung Re na yun is directed on the part of the bar AB. Kasi nga lumalabas, non-existent na ngayon yung cylinder natin at maging existent na ngayon yung tinutukoy natin vertical bar AB. So, sabihin, yung direction ng pinaka-vector, yung reaction na yon, pupunta siya doon sa mismong pinaka-visible part. So, ayan. So, gawa na natin ng separate free body diagram, itong pinaka-cable AB natin. So, para mas maintindihan nyo yung concept, no? So, gawa natin ng isolation. So, lagay lang natin dito is isolate bar ABD. So, isolate bar. So, yung bar natin is ito. So, yung bar natin is you have ABE. ABE or AEB. Bar AEB. So, gawa natin ng separate isolation or gawa natin ng corresponding free body diagram. Ayan. So, tingnan natin yung configuration natin. So, yung pinakadulong part niya is labeled as B. Yung pinaka part or point kung saan merong contact yung mismo yung tangential contact ng mismo pinaka-cylinder natin with respect to sa flat surface ng AEB ito. Tapos ito naman si A. So again, basta't meron kayong tali or cable, yung cable na yon is always subjected to the force of tension. So again, dalawa lang yung possible direction. So kung vertical, up and down. Kung horizontal naman, you have left or right. So in this case, pwede siyang up, pwede siyang down. So hindi po pwedeng up kasi yung tendency nun, tumutulak yung cable, which is actually not the case. Ang cable hindi pinantutulak, rather ang cable pinambabatak. Ayan. So since ito naman is location at T, yan. So lilabel natin to as TBD. So TBD to. TBD. So once again, sinabi ko sa inyo, for as long as meron kayong makikita ditong vector or force, so in this case, tension yung force natin dito, na inclined, i-breakdown natin siya sa kanyang x and y components of a force. So, yan. Then, eto. So, TBD. So, ito is labeled as TBD of x. So, TBD of x, ito naman is labeled as TBD of y. So, kung titingnan natin, no? So, kung wala itong pinaka-cylinder na to, ang tendency ng pinaka bar AB natin, pupunta siya doon sa may leftmost portion kasi binabatak siya ng cable, PT. So in this case, meaning may part itong pinaka-cylinder natin. At ang part ng cylinder na to is to push this vertical bar AAB towards this particular portion or towards the right. So in this case, itong pinaka-cylinder natin, nagbibigay siya o nag-exert siya ng reaction. At yung reaction na in-exert niya is basically ito. So, ito yung reaction na binibigay ni cable, ni cylinder. So, ang reaction na binibigay ni cylinder is yung RE. Kung saan yung RE natin was previously computed to be at the value of 577.35 pounds. So, ayan. Ayan, ano? So, base dito sa configuration natin, yung angle natin dito is you have 60 degrees. Yan. Diba? Then, kung i-assess natin ngayon yung corresponding configuration, ang sabi nga dito, no, base dito sa ating observation or analysis, yung RA of X natin is directed to the left, although assumption pa lang yan. Pero check natin kung tama. Tapos si RA of Y either going up or going down. So gagawin natin siya. So again, si RA of X is directed to the left. Tapos si area of Y either going up or si area of Y is going down. Ayan. So, kung titinan natin ngayon yung ating figure, pwede na tayong gumawa ng equation, pero complete muna natin. So, lagay na natin dito yung distance. So, base dito sa figure, no, ang distances natin is you have 5 foot of 5 feet. Tapos you have 3 feet. So, ayan, 5 feet saka 3 feet. So, again, kung titinan natin, no, base dito sa configuration natin, so far, ang may value pa lamang tayo dito is actually yung value ng RE. So, RE may value. So, tinanong natin walang value. Area of X, wala. Area of Y, wala. TBD or TBD of X or as well as TBD of Y, wala. So, meron lamang is RE. So, again, kung titingnan natin yung corresponding isolation or free body diagram, once again, tingnan natin kung applicable yung tatlong formulas. So, vertical equation, horizontal equation, moment summation. So, what if tayo ay mag-take ng vertical equation? Kung tayo mag-take ng vertical equation, counted si TBD of Y, counted din si RA of Y. Problem is, wala tayong TBD. So, hindi natin po pwedeng gamitin yung TBD of Y. At wala rin tayong RA of Y. So, means say, hindi po pwede yung ating vertical equation. So, what if ang gawin naman natin is gumawa tayo ng X equation or horizontal equation? So, horizontal equation, consider natin lahat ng horizontal components of force, TBD of X. So, again, since wala tayong TBD, hindi natin pwedeng kuhanin yung value ng TBD of X. Another one is wala tayong value ng area of X. Diba? So, in this case, lumalabas dalawang unknown. Although, meron tayong reference value which is RE. So, paano naging reference value? So, reference value in the sense na previously nakuha natin, na-compute natin yung value ng RE. So, again, meaning say, kung tayo magtitake ng X equation or horizontal equation, tatlo yung lalabas doon sa ating X equation, si TBD of X, si RE, saka si RA of X. So, since dalawa sa tatlong components na to, ang ating X equation is unknown, hindi pa rin natin po pwedeng gamitin si X equation. So, yung last formula that has yet to be used is yung moment summation. So, sa moment summation, gaya nga sinabi ko sa inyo, for as long as meron tayong location at meron mga corresponding perpendicular distances, pwede nating gamitin yung moment summation. So, check natin. So, malinaw na malinaw, meron dimensioning. Tapos, kung titignan natin, may mga orientation yung mga forces natin. So, meaning, meron tayong mapagkukuhanan ng perpendicular distance. So, ano ba yung mga forces natin? So, si TBD, bibreakdown natin sa TBD of X saka TBD of Y. So, meaning, hindi na natin makikita si TBD. Then, bilang natin. So, TBD of X, TBD of Y. So, you have 2. RE, you have 3. RA of X, you have 4. Then, RA of Y, you have 5. So, all in all, meron tayong 5 forces that are actually present dito sa ating configuration na magiging possible part ng ating moment summation. However, kung tayo magtitake ng moment summation at B, at E, or at A, mayroong mga forces na mawawala doon sa ating moment summation, in particular due to the absence of their corresponding perpendicular distances. So, ang point ko lamang is kung magmong-moment man tayo sa B, sa E, o kaya sa A, mawawala si TBD of Y as well as si RA of Y. So, in this case, lumalabas, gaya sinabi ko sa inyo, so, you have 1, you have 2, you have 3, you have 4, you have 5. 5 possible forces. Pero kung kayo magmo-moment sa B, sa E, or sa A, mawawala si TBD of Y as well as si RA of Y. At kung kayo ay magmo-moment sa B, aside from mawawala si TBD of Y saka si RA of Y, mawawala din si TBD of X. So, lalabas si RE. Then, lalabas din si RA of X. Or, kung kayo mag-moment summation at A, mawawala si RA of X, mawawala din si RA of Y as well as si TBD of Y, magpapakita ngayon si RE at magpapakita din si TBD of X. So, in both cases, possible kung tayo mag-moment summation sa B or mag-moment summation at A. However, magiging problem natin is kung kayo man ay magtitik na moment summation at E, hindi possible. Bakit? Kasi kailangan natin ng given. At ang given na yon ay manggagaling kay RE. So far, ang RE natin is 577.35 pounds. So, sabihin, from 3 possible locations kung saan tayo po pwede mag-take na moment summation, hindi po pwede na tayo mag-moment summation at E kasi nga mawawala yung ating given data o yung pagbabasihan. So, either at B or either at A, yung possible locations kung saan tayo po pwede mag-take na moment summation. So, let's say for example, nag-take tayo ng moment summation at A. So, moment summation at A, all forces going the clockwise direction is considered to be positive. So, pag tayo ay nag-take ng moment summation at A, So, mawala si RA of Y, RA of X, as well as si TBD of Y. So, lalabas lamang si RE saka si TBD of X. So, check na. So, tiyan natin. So, kung iikot tayo, yan. So, since yung pinaka-direction ng turning motion is along sa direction ng RE, so si RE is actually positive. So, positive RE. So, mula E, papunta doon sa A, have perpendicular distance of 3. Yan. So, since dalawa lamang magpapakita dito, RE sa TBD of X, most probably, negative si TBD of X. So, check natin. So, iikot tayo sa A. So, papasin nyo, ito yung turning motion. So, sa lubong, so, since counter yung turning motion sa direction ng TBD of X, mean say negative si TBD of X, which is na-validate nga natin. So, again, moment is described as force multiplied by perpendicular distance. So, magmula A, papunta sa TBD of X. So, you have 3 plus 5, you have 8 is equivalent to 0. So, ayan. So, in this case, breakdown natin yung TBD of X. So, lagay muna natin RE. Ang RE value natin is you have what? Ang RE value natin is you have 577.35. 577.35 multiplied by 3. Equate na natin. So, tanggalin natin si equivalent 0. Equate na natin sa TBD of X. TBD of X is TBD cosine. At ano angle? Ang angle natin, which is that of X, is 60. Yan. So, in this case, pwede natin ngayon kuhanin yung value ng TBD. So, TBD value, you have 577.35 times 3 divided by cosine ng 60. So, nakaligtaan ko pa yung perpendicular distance, which is 8. So, perpendicular distance is 8. Ayan. So, ulitin natin. 577.35 times 3 divided by cosine ng 60 divided by 8. So, you have actually, may mali, So, mali. So, mali ko pala dito is actually ganito, So, yung correction nga pala sa figure is actually ganito, kung ito is 60, since yung 60 nito is with respect sa vertical, theta of x to. So, since yung 30 nito is with respect to sa horizontal, ito yung theta of x. So, ang correction na dapat kong gawin is ito. So, hindi siya 60. Rather, ang angle dito should be 30. So, again, bakit 30? So, again nga, kasi ito is actually 60. So, 60 saka 30, you have a total angle of 90. So, ayan. So, i-correct lang natin. So, you have 30. So, ayan. 577.35 times 3 divided by cosine ng 30 divided by 8. You have 249.999 or you have 250. Gawin na natin 250, So, you have 250 pounds. So, meron tayong TBD. Yan. So, nasagutan na natin yung isa sa mga requirement. Ang sabi dito is, what tension in the cable BD would exist as a result of the placing of the 1,000 pound cylinder? So, tension in the cable BD is equivalent to 250 pounds. So, last one is, what reaction exists at pin A? So, kung titingnan natin yung A, sa A, meron tayong area of X saka area of Y. So, supposedly, man natin area of X saka area of Y, gamitan natin ng resultant formula. Eventually, we could solve for the single reaction existing at pin letter A. So, paano natin makukuha yung value ng So, ang gagawin natin dito is, so far, nagamit na natin yung moment summation. So, sunod natin dito is yung ating vertical equation. So, vertical equation. So, summation forces vertical. All forces going up are considered to be positive. So, base dito sa configuration, dalawa lang naman yung ating vertical force. So, TBD of Y, negative, TBD of Y. Then, so, ito hindi na pala tayo kinakailangan mag-assume dito. Base dito pala sa may direction ng TBD of Y, ito na ngayon magdidictate kung ano dapat yung value ni array of Y. So, ang pipili nating array of Y should be positive. So, since dalawa lamang naman yung vertical, TBD of Y sa array of Y, pwede natin sara. So, equivalent to 0. So, again, summation forces vertical, all forces going up are considered to be positive, whereas all forces going down are considered to be negative. So, TBD of Y going down, negative. So, para ma-counter, ma-offset natin yung negative sign convention ng TBD of Y, ang i-affix natin sign convention on the part of array of Y should be positive. So, ayan. So, breakdown natin si TBD of Y. So, TBD of Y, you have TBD, sign ng, ang angle natin is 30 is equivalent to RA of Y. So, ayan. So, TBD value, you have 250. Sin ng 30 is equivalent to RA of Y. So, compute na natin yung value. So, you have 250 times sin ng 30. So, ang area of Y has a value of 125 pounds. So, area of Y, you have 125 pounds. Ayan. So, last one, to solve for the value of area of X. So, area of X, kung titignan natin, horizontal to. So, kung horizontal to, so far kung titignan natin, hindi pa natin nagagamit na formula is yung summation forces of X. Although, for us to be able to solve for the value of area of X, pwede rin tayo mag-take na moment summation. Pero hindi na applicable yung moment summation at A. So, pwede tayo mag-take na moment summation at B for us to be able to solve for the value of area of X. Or, simply put it, pwede natin gamitan na mas madali equation which is yung X or horizontal equation. So, gamitan natin ng horizontal equation. Summation forces of X, all forces going to the right are considered to be positive. So, kung titignan natin yung ating configuration, you have 1, TBD of X, you have 2, RE, then last one, you have 3, RA of X. So, since TBD of X natin is directed to the left, negative siya. Negative TBD of X. Since yung RE natin is going to the right, positive RE. Then, RA of X, ang assumption natin is going to the left. So, hopefully, tama to, no? So, minus RA of X is equivalent to 0. So, again, ang ultimate goal is makuha natin yung RA of X. So, breakdown natin yung TBD. So, kung titignan natin, yung RA of X natin dito is negative. So, meaning, pwede natin equate itong dalawang part na to, TBD of X saka RE with respect sa RA of X. So, hindi na natin babaguhan yung sign convention ng TBD of X saka ng RE. Ang papalitan lang natin sign convention is si RA of X. So, lumalabas, negative TBD of X plus RE is equivalent to RA of X. So, breakdown natin. So, you have negative TBD cosine ng 30 plus RE is equivalent to RA of X. So, TBD value, ang value niya is you have negative 250 cosine ng 30 plus yung value ng RE. So, ang RE natin dito, you have 577.35. So, 577.35 is equivalent to RA of X. So, in this case, RA of X is equivalent to what? Negative 250 cosine ng 30 plus 577.35. So, ang bali ng area of x natin is you have 360.844. So, 360.844 pounds or libras. Ayan. So, since nakuha na natin yung value ng area of x saka area of y, and since ang question natin dito is what reaction exists at pin A, so kung titignan natin at A, dalawa yung corresponding forces natin, area of x saka area of y, it is possible to simplify two or more forces by means of a single force, at ang tawag sa terminology na yon is what we call the concept of the resultant. At ang resultant formula is base do sa Pythagorean theorem formula. So, lumalabas, RA, you have square root ng RA of x square plus RA of y square. So, RA of x, you have 360.844 square plus you have 125 square. Kuhanin natin yung square root. So, 360.844 square plus 125 square. Kuhanin natin yung square root. So, you have 381.81. So, RA is you have 381.881 pounds. Ayan. So, nakuha na natin yung hinahanap, yung corresponding tension on the cable BD and then yung corresponding reaction on the part of pin located at A. Now, to check if tama ba or to validate kung tama ba yung mga na-obtain natin mga values, possible pa rin yun. At gagamitin natin nga is yung ating original free body diagram. So, gagamitin natin tong original free body diagram that was not used previously. So, gagawa na naman tayo ng another isolation. So, gawa lang tayo, no? So, magre-redraw lang another figure dito. Gayahin lang natin yung gagayahin lang natin yung isolation ng free body diagram natin as a whole. So, magre-redraw lang muna ako. So, RE is equivalent to 577.35 pound. Yan. Tapos ito naman is what we call tension. Tension on the part of cable BD. Yan. So, papakita lang natin. So, pinapakita ko lang comprehensively yung solution dito. Although nasagutan na natin eh. So, may option naman ako na hindi sagutan to. So, pero for your own sake, para mas maintindihan yung concept natin ng equilibrium, much better na makita nyo yung discussion from all possible angles. Ayan. Tapos, RA of X is equivalent to 360.844. Tapos, RA of Y you have 125 pounds. Ayan. So, checking so for checking purposes, gagamitin natin yung whole free body diagram. So in this case, we'll be making use of only the summation forces vertical sa summation for horizontal equation. So hindi na natin po pwedeng gamitin yung moment summation kasi nga on the part of the cylinder, walang mga perpendicular distances. So unahin natin yung horizontal equation. Summation forces of X, all forces going to the right are considered to be positive. So ano yun? TBD of X directed to the left, negative. Negative TBD of X. So in this case, papasin nyo, ito yung E. Sa E, kanina, merong RE. Diba? So in this case, sir, bakit nawala yung RE? So, in case na let's say for example, meron kayong paghiwalayin na dalawang object that is actually adjoined at two common locations, doon lamang lalabas o doon lamang mag-reflect yung corresponding reaction. Pero if ever in the case na hindi nyo pa rin sila paghiwalayin or i-disassemble, wala kayong makikita corresponding reaction. So, yung reason kung bakit wala kayong makitang RE, pero previously, sa previous computation solutions natin, meron kayo makitang RE value. So, lumalabas, actually, may mali pala ako dito, no? So, ang mali ko dito is actually ito. Ang kailangan ko palang value is R. So, R siya, pero ang nilagay ko is RE. So, R lang. So, sorry. Ulit. So, i-rectify lang natin yung solution. So, gamit tayo ulit ng ating mahiwagang correction tape. So, R is you have 1154.7 pound. Ito is RX. Ito naman is RY. So, ayan. So, TBD of X directed to the left, so hence negative. So, RX going to the right. You have positive RX. Then, last one, you have array of X. So, directed to the left, negative array of X. So, since wala na, it's equivalent to 0. So, breakdown natin. Once again, negative TBD cosine ng 30 plus Rx minus Ra of X is equivalent to 0. Ayan. So, TBD value, ang TBD value natin is, you have 250. So, negative 250 cosine ng 30 plus yung value ng Rx. So, Hindi ko pala na-breakdown, no? Pakita lang natin ang breakdown nito. So, Rx is you have R, tapos ang angle is 60. So, R cosine ng 60. Ayan. R cosine 60 minus area of x. So, R value, you have 1154.7 cosine ng 60 minus area of x value, you have 360.844 pounds is equivalent to 0. So, validate natin kung magsi-0. So, negative 250 cosine ng 30 plus 1154.7 cosine ng 60. Yan. So, itong part na to, positive 360.8436 minus, you have 360.844. So, in difference is you have negative 3.5, 5095 times 10 raised to negative 4. So, ayan. So, is almost equivalent to 0. So, para mas makita nyo na talagang konting-konti na lang diferensya para siya is almost 0. So, negative point, so in decimal form, 0.0003595 almost equivalent to 0. Ayan. So, again, ano yung reason kung bakit hindi siya nag-equal to 0? Kasi ang tendency, hindi natin ginagamit yung true value niya. So, check na to, no? Ayan. So, base dito, no, ang di ko lang naipalawan nga pala kanina, no, sa pagbabalidate natin. So, since consider na natin lahat ng horizontal components of force, wala ngayon tendency na yung force natin na horizontal is mag-sway towards the right or mag-sway siya towards the left. So, in this case, stationary na ngayon yung ating configuration. So, stay put siya, hindi na siya mag-move sideways. So, ang isa nilang is to prove na hindi siya mag-move up and down. So, to prove na hindi siya mag-move up and down, gamitan natin ng y equation or vertical equation. Ayan. So, ano yung mga vertical equations? So, you have TBD of y, negative 1,000, negative area of y, which is positive. So, negative, yung pa pala, ry pa pala. So, positive ry muna tayo. So, positive ry minus TBD of y minus 1,000 plus RA of y is equivalent to 0. Ayan. So, breakdown na natin yung ry. So, positive r, sine ng angle is 60. Minus TBD, ang angle is you have 30. So, sine ng 30 minus 1,000 plus area of y is 125 is equivalent to 0. So, again, once again, no, pag sinabi nating y, i-breakdown siya. Ang conventional na pagbe-breakdown sa kanya is in terms of theta of x. So, pagka theta of x, tapos in terms of y, sine. Ngayon, pagka siya na may x at ang angle na involved is theta of x, instead of sine, ang gagamitin natin para may breakdown o ma-elaborate is actually cosine. So, R value natin is you have 1154.7. So, positive 1154.7 sine ng 60 minus TBD value, you have 250 sine ng 30 minus 1,000 plus 125 is equivalent to 0. So, validate natin kung tama ba. 1154.7 sine ng 60 minus 250 sine ng 30 minus 1,000 ulit. So, 1154.7 sine ng 60 minus 250 sine ng 30. So, 125 siya. Double check lang natin, no? So, you have what? Para ma-check lang natin. So, double check 1154.7 sine ng 60. Ayan. So, ito yun. Minus 250 sine ng 30. So, minus 1,000 plus 125. So, ang simplified value nitong solution na to is you have negative 4.6625 times 10 raised to negative 4. So, ayan. So, in decimal form, you have negative 0.00046625, almost equivalent to 0. Ayan. So, na-prove natin, since konting-konti lang naman yung difference, so actually, negligible na to eh. So, 0 na rin siya. So, na-prove na natin na yung whole structure natin will not move sideways or hindi siya mag-move up and down. So, yan. So, pwede na natin ngayong i-box yung ating sagot. Dito, balikan natin, no? So, lagay lang natin. So, cable BD tension, T BED, you have 250 pounds. Tapos, reaction at pin A, RA is equivalent to 381.881 ounce. So, ito na ngayon yung ating final answer para dito sa ating problem statement. So, ayan. So, once again, i-scan ko na lang itong solution that I had generated for this particular problem statement. Para let's say, for example, gusto nyo siyang i-review, meron kayong ma-access na hard copy. So, ayan. Ito siya. Then, ito yung second page niya. Then, yung last page niya is ito. So, again, hopefully, naintindihan yung concept ng equilibrium of a force. So, essentially, we'll only be making use of three formulas. Summation forces vertical, summation forces horizontal, as well as summation of moment. So, yun lang guys, ano? So, hopefully, naintindihan nyo. So, goodbye.